Hey guys, welcome to what will be week 4 of our online learning. All I have for you this week is basically this one lesson, which is 10-2, and I'm going to split it into 2 separate videos. You'll have 2 separate mastery assignments to submit and 2 separate homeworks, and that's basically it. They'll be the same mastery worksheet, but just different problems like we've been doing. So here's your first bell ringer. Give it a try, see what you come up with. All right, so there's a few different ways to do this, but first step should definitely be subtracting 21 from both sides, because we want to have everything on the left like that. If we're relating it to what we've been working on recently, then you would take this whole thing and type that in your y equals, right? And then go over to calculate 0, do your left bound, right bound, that whole deal, and find your 2 solutions. So that would probably be the main way to go. You could, for the record, also try to factor that if you feel confident in your factoring abilities, and that would be x plus 7 and x minus 3 in parentheses, because 7 minus 3 is 4, and 7 times negative 3 is negative 21. And then you would just set each of these equal to 0. And you'd solve both of those for x. So the first one you'd subtract 7, so that would give you x equals negative 7, and second one you would add 3, so that would give you x equals positive 3. So those would be your 2 solutions. And if you did it on a calculator, you're going to see that you got those same 2 solutions, and if I check here, same 2 solutions. So a couple different ways to do that. Alright, so new chapter here, skipping 10-1, going right to 10-2 here. Basically, we're looking at radicals, okay? Now, radical is what you might call the square root symbol, right? You see it a number of times on here. You see it right there, for example, right there, right there. Those are all called radicals. In this case, the way that they look right here on this slide, they are square roots. The reason we say radical is because I might have, and I do think we saw this earlier on in the year, if I have, say, a 3 up there, it's a weird looking 3, if I have a 3 up there, then it's no longer a square root. It's called a cube root, or a third root, but it's still a radical anytime we have that symbol there, okay? So we're going to be looking at how do we simplify these, basically. And like I said, we're basically going to do the first half of this lesson today. So it all comes down to factor trees. If you have square root of 52, okay, what we need to do is we need to split this up into 2 numbers, and we need to find 2 numbers that multiply to give us the number 52. Now that's not a super common number that we're multiplying to, so it might take you a little bit of time. But one thing I always say is if you're struggling to find numbers that go into 52, if you look at it and it's even, then you know that 2 definitely goes into it, right? In other words, 2 times something gives me 52. And if you're not sure what that number is, you could pick up your calculator and type in 52 divided by 2, and that's going to tell you the number. Okay, so in this case, the number is 26, or maybe you were able to just figure out in your head 2 times 26, okay, whatever works. Now I need to look at those 2 numbers and say, can I break them down any further? If I try to break down the number 2, it's not going to work. It's just 2 times 1, right? Because this is all multiplication, not adding. And I don't want any 1s here. Those don't really count, okay? So 2 is as far as I can go. The other thing we could call this is we're basically doing what's called a prime factorization. That's the same thing that a factor tree does. And that means that at the bottom of all our little roots of our factor tree should be prime numbers. Numbers that the only way you get them is you multiply 1 times that number itself. So just like you saw with 2, the only way I can get 2 is 2 times 1, or 1 times 2, which is why it's prime. 26 is not prime, because there are numbers that I can multiply together to give me 26. Again, if you're not sure, just look at 26 and realize that it's even, so 2 goes into it, and in this case 2 times 13 is how I get 26. We already said I can't break 2 down anymore. Now I look at 13 and say, can I find 2 factors of 13, 2 numbers that multiply to 13? And the answer is no. 13 is actually prime as well. So we're finished with our factor tree. We broke it down as far as we possibly could. We can't break 2, or 13 down any more than we already have. So what do we do next? What you want to do is, because all we're looking at is a square root, which means the second root, we're looking for groups of 2, or pairs. So for example, there's a pair of 2s. So I always circle the pair. And I do think we did this earlier on in the year, so if you're sitting there saying this seems somewhat familiar, then that's probably why. Okay? So we have a pair of 2s, so we circle our pair. If you had any other pairs, you would circle that pair as well. And what I do is any number that's not paired up with something, so in this case 13, I put it in a box. That way we don't miss it. Okay, so that number did not have anybody to pair up with, it's just by itself. Now you might be wondering, what about the 26 in there? We don't count any numbers that are not at the bottom of the factor tree. Okay, so 26 got broken down further into 2 and 13. So I don't care about 26 anymore. I'm looking at the 2 and 13. Okay? So we've done everything we can do here in terms of circling and putting numbers in boxes. Now we just have to write our answer. When we have numbers circled, so in this case we have a pair of 2s because we were taking the square root, that goes first. So I'm going to write 1, 2. I know I have 2 2s in the box, but they count as 1 now. It's just a pair. It's a couple. Okay? So that 2 is on the outside now because of the fact that that pair got circled. And then whatever you had in a box, you didn't have it pair up with anything, like 13 here, that goes under your radical, or your square root. Okay? And that, in this case, would be your final answer. The 2 goes on the outside, 13 goes on the inside. Right? That's an easy way to say it. All right, let's look at another one. And by the way, you can check your answers on these by typing in the original problem in your calculator, square root of 52, and that's going to be some weird decimal. Let me type it in quickly so I can talk you through this. So if I type that in, it gives me 7.2111, and then it keeps going, right? Some weird decimal. Then if you type in what you think the answer is, so if I just type in 2 square root 13, it gives me the same weird decimal. That's how I know I got the answer correct. Okay. And the only other thing that's possible is maybe you didn't break down your factor tree, or break down your factor tree as far as you could have, but hopefully that doesn't go wrong. So that's how you check them. All right, 45. So what goes into 45? There's a few different things you could think of, but maybe one of the common ones you'll come up with is 9 times 5 or 5 times 9. Order doesn't matter. Okay, the other one you might have thought of is 15 times 3. That's fine. Now we look at these, 9 and 5. Well, 9 can get broken down. That's 3 times 3. 5 cannot go any further. 5 is already a prime number. And these 3's cannot go any further because they are prime numbers now as well. 3 and 5 are both prime. So now we got to do our circle box thing. So we have 2 3's. You have a pair right here. We're going to circle those. There's our pair. And then the 5 goes in a box because it does not have another 5 to pair up with and get circled. Again, the 9 is old news. We don't care about the 9 because it became those 3's. Since the 3's are paired up in our circle, we write a 3 on the outside, and then the 5 goes on the inside of our radical. That's it. And again, you could check with the calculator, like I said, but that should be our answer here. All right. So these are a little different, and we'll see a few different things here that sort of need to be addressed. The best way to do these ones is to do two separate factor trees, basically. Okay, we're going to do one on our first radical, which is just that square root of 2, and then one on our second, which is the square root of 24. Square root of 2, as we said earlier, 2 is already a prime number, can't go any further. The only thing in this case I'm going to do is just draw one line and write a 2 there, just so I could see that that's down there. You'll see kind of why that makes sense in a second. Now let's look at the 24. And you could do this off to the side if you want more space or whatever. But so 24, I'm going to say that's 2 times 12. You could have said 8 times 3 or 6 times 4. Okay. Either way, these work because you're going to get the same numbers at the bottom of your factor tree. It's just going to look a little different along the way. 12 I can break down into, let's do 4 times 3. Again, you could have done 6 times 2. That's fine. And then 4 becomes 2 times 2, and the 3 can't go any further. So now I've done a prime factorization, or a full factor tree on both of these radicals. Now I got a circle and box. There's a pair of 2's. Here's a pair of 2's. So that's kind of why I drew this little line right here to begin with, to put that 2 there, because I knew that, it wasn't that I knew it was going to pair up with anything, but it was that I wanted to see if it would. Right? And in this case, it did. So I just like to have it down there so I can consider it. So there's a pair. And then 3 goes in a box. 4 and 12 are both old news. They both got broken down further. So this is a little bit different. Okay? We have 2 pairs of 2's, and then we have 1 3. Well, we should know that the 3 is going inside our radical. Right? That's pretty easy. So the question is, what do I do with those 2 pairs of 2's now? Right? Well, they're basically both going on the outside. So it's a 2, and then it's another 2, and then you should be wondering which operation goes in between. The answer is multiplication. Okay? And it's not just because the problem was multiplication. It's because anytime you're doing this and you have these pairs, they both go on the outside and they get multiplied. So 2 times 2 is 4. So this is going to be 4 root 3 as our answer. You could, let me just wipe all this clear real quick. You could, if you want to, multiply those 2 numbers in the radicals first. In other words, 2 times 24 is 48. So I could say that's the square root of 48, and then I could get to work on 48. Maybe I say that's 4 times 12, and I keep going from there. You'll get the same answer. The problem with that method is sometimes the numbers you're starting with are pretty large, right? And then you're going to end up with a pretty big number here that takes you a while to do a factor tree on. So I think that's the longer way to do it. But if that is what you prefer, then that's fine. 4 root 3. Let's do another one quickly. So 5 is already prime. So again, I'm just going to draw it there. I can't do anything with it. 35 is 5 times 7. So there's 2 5's and 1 7 because all those are prime now. So this is just going to be 5 root 7. Okay. All right. A couple more problems to look at here. So you're going to have some that look like this now. They have variables in them. We're still going to start the same way, right? We're still going to start with 45. Whoops, my screen just got really big all of a sudden. And we already did 45 recently, but it's okay. We could just do it again. We said it was 9 times 5 and 3 times 3. So we had a pair of 3's and then a 5 in a box, right? So we know we're going to have a 3 outside and a 5 inside. But what do we do with our variables? Well, if I have a to the 4th, right, and I want to do a little factor tree on that, it's basically a times a times a times a. 4 a's, which means I have 2 pairs, right? If I do b to the 5th, 1, 2, 3, 4, 5. So 5 B's. So I have a pair, and then I have one that does not pair up. Right? So you can think about it in that way if you want to. You can go off the side and do that if you feel like you need to do that or if that's going to benefit you. But the shortcut is, so here, maybe this is quicker. Okay. The shortcut is, if I have a to the 4th, and I'm taking the square root, which means, like we've been doing, it means we're looking for groups of 2. All you got to do is divide 4 by 2. Your exponent up there is 4. If you divide it by 2, that becomes 2, right? 4 divided by 2 is 2. So that means you're going to have an a squared on the outside. So let me start writing our answer. We have these 3's that got paired up, so they're going out. So 3 on the outside. We're eventually going to have a 5 on the inside because of what's in the box right here. So 3a squared, let's look at our b's, right? And we already kind of drew it out there, but if I have b to the 5th, another way to think of it is how many groups of 2 do I have in 5? I have 2 groups of 2, right? I have the first 2, I have the second 2, and then the 5th one's by itself. So 2 groups of 2 means I'm looking at b squared on the outside, and then I got to remember that I'm putting 1 inside. And then when I look at c to the 6th, that would be 3 pairs of c's, right? So c cubed, or c to the 3rd on the outside. And now I'm sort of running out of space. Let me write this down here. 3a squared, b squared, c cubed. So that's where we're at so far. That's everything that's on the outside. What's on the inside? We have our 5 from our box. We don't have any a's because it was a to the 4th, and that was just 2 groups. That was it. We have a b because that was b to the 5th, so that 1 got left by itself. And then when I look at c to the 6th, we don't have any left over there. That was 3 pairs, and that was all. So there's your answer to this one. Hope that's making sense. Okay. Now they draw some absolute value there and stuff. Don't worry about that. We're not gonna worry about that right now. Let me do one more quickly. So 32 is, let's say, 4 times 8. 4 is 2 times 2. 8 is 4 times 2. And 4 is 2 times 2. So I'm just breaking this down really quickly. 2 groups of 2's and 1 left alone. So since I have 2 groups of 2's, that's 2 times 2 on the outside. So 4. We're starting out with a 4. Then I look at my m's. It's m squared. So that's just 1 group of m's, or m to the 1st on the outside. Same with my n's. It's n squared, so that's just going to be n by itself. When I look at c, there's only 1 there. So I can't bring a c out. That c is by itself. So I'm done putting stuff on the outside. We had this 2 that we boxed up, so that's going in. There are no m's left, no n's left, because those already got brought up to the outside. And then we just have that c that was by itself right there. Hope that's making sense. All right. So there it was. And again, don't worry about the absolute value bars. There's your homework. Let's jump over to the huddle. And you're going to do numbers 1 to 6 on here. So pause the video, give those a try. And here are the answers. Number 1 is 6 square root 2. 2 is 3 square root 11. 3 is just 15. 4 is 48. 5 is 9ad squared. 6 is 2x squared y cubed square root 10. So if those went well for you, then you're going to jump to the mastery and you're going to do just numbers 1, 2, and 3, as you see right there. So 1, 2, and 3 on the mastery, and then again, there's your homework. Check back in for the continuation of this lesson.